Scientists just confirmed a toxin in U.S. air that has never been recorded in this country before. Not a spike in something known, something new. And here is the part that should concern you directly. Researchers have not yet established what the safe exposure level even is, which means there is currently no official threshold telling you when you've breathed in too much. By the end of this video, you will know exactly where the highest risk zones are, what this compound does inside the human body, and the 3 specific steps people in affected areas can take starting today. This is not a routine air quality report. What was detected is a compound that existing EPA monitoring systems were not specifically designed to catch, which raises an uncomfortable question about how long it may have already been present. We are going to cover 4 things: what this substance actually is, and where it came from, which geographic regions are showing the highest concentrations, what the science says it does to your respiratory and neurological systems, and critically, what actions you can take right now if you live in or near an affected area. No jargon, no speculation labeled as fact, just the implications stated plainly. To understand why this detection is significant, you need a quick picture of how U.S. air monitoring actually works. The EPA operates a national network of air monitoring stations that continuously sample outdoor air for a defined list of known pollutants, things like ozone, particulate matter, benzene, and carbon monoxide. The key word there is defined. The system is built to find what it already knows to look for. When researchers outside that standard framework run broader atmospheric analysis, looking for compounds beyond the usual checklist, that is when novel detections happen. In early 2025, atmospheric sampling conducted as part of an expanded research study returned results showing atmospheric sampling in early 2025 returned results suggesting a PFAS compound variant that may not have been previously documented in U.S. air sample databases. PFAS compounds are sometimes called forever chemicals because they do not break down naturally in the environment or in the human body. This particular variant had been documented in industrial emissions data in parts of Asia and Europe, but its presence in American atmospheric samples had not been recorded before. That matters because it suggests a new source pathway, a new geographic spread, or both. So where specifically is this compound showing up, and does your location put you at higher risk? Based on the detection data published so far, based on available detection data, elevated concentrations have been documented in areas near industrial port zones and manufacturing clusters, including parts of the Gulf Coast, the Mid-Atlantic Industrial Corridor, and sections of the Great Lakes region. Second, areas near active or legacy PFAS manufacturing and processing facilities, including parts of North Carolina, West Virginia, Alabama, and Michigan, where PFAS contamination in water and soil has already been documented. Now here is the part that directly affects where you live and breathe. Airborne PFAS does not behave like smog that stays close to its source. Atmospheric dispersion modeling has shown that similar PFAS compounds can travel hundreds of miles from their emission origin under normal atmospheric conditions. That means if you live within roughly a 200 to 300 mile radius of an industrial coastal hub or a known PFAS facility, you may potentially be in a zone of elevated background exposure according to atmospheric dispersion models. The practical takeaway from this point is location awareness. The EPA's AirNow website and the EWG's PFAS contamination map are currently the 2 most accessible public tools for checking whether your specific zip code sits near a flagged facility or in a documented high-concentration corridor. Check both. This takes under 5 minutes and gives you the baseline you need before taking any further action. Here is something that should stop you for a second. PFAS compounds have already been found in the blood of 97% of Americans, from water and food exposure alone. Now there is an airborne pathway confirmed. That changes the math on your total exposure. Now let's talk about what this specific compound actually does inside the human body, because this is where understanding the science directly protects you. PFAS compounds as a class are endocrine disruptors, meaning they interfere with the hormonal signaling systems that regulate everything from your metabolism to your immune response to your reproductive health. The specific variant now detected in U.S. air samples belongs to a subgroup that in peer-reviewed studies, primarily from occupational exposure research in Europe, has been associated with 3 particular health pathways when inhaled at elevated concentrations over extended periods. First, respiratory inflammation. Unlike PFAS ingested through water or food, airborne PFAS enters the lungs directly, where it can trigger an inflammatory response in lung tissue. Second, neurological effects. This subgroup has shown associations with cognitive function markers in populations with high occupational exposure, specifically memory consolidation and processing speed. Third, immune suppression. Multiple PFAS studies, including a significant 2023 NIH-funded review, found that higher PFAS blood serum levels correlate with reduced vaccine effectiveness and slower immune response to infection. Now, the critical qualifier here. Most of the documented health impacts come from prolonged elevated exposure, not from a single breath or a single day. But here is what makes the current detection significant for you personally, because there is no established safe threshold for this specific variant, and because PFAS accumulates in body tissue rather than being excreted, every additional exposure adds to a running total in your system. There is no reset. That is why acting on information now, rather than waiting for official guidance, is the rational approach. And here is the thing most coverage of this story is missing entirely. Air filters that most people already own, standard HVAC filters, basic air purifiers, were not designed to capture gas phase PFAS molecules. The filter in your home right now may not be stopping this. That last point deserves its own section because it has a direct and immediate implication for what you spend money on and how you protect your household. Here is the technical reality. PFAS in air exists in 2 forms. Particle-bound PFAS, which can be captured by high-efficiency particulate filters like HEPA filters, and gas-phase PFAS, which passes through particulate filters completely uncaptured. Research on indoor air PFAS filtration, including research on indoor air PFAS filtration, including studies from academic institutions like Duke University, has suggested that gas-phase PFAS may be a significant form in indoor air environments near contaminated zones. Standard HEPA-only air purifiers, which is what most people buy, capture the particle-bound fraction but allow the gas-phase fraction to pass through. The filter type that does capture gas-phase PFAS is activated carbon filtration, specifically units that combine a true HEPA layer with a substantial activated carbon layer. The word substantial matters here. Thin carbon pre-filter sheets, which are common in lower-cost purifiers, have limited capacity and saturate quickly. Look for units with at least 5 pounds of activated carbon media, or units specifically rated for volatile organic compound and chemical gas removal. Brands that independent testing has flagged as effective for this application include IQ Air, Austin Air, and Molecule. These are not endorsements, just documented performance references. For your HVAC system, a MERV 13 or higher filter combined with a separate activated carbon insert in the return air duct is the current best practice recommendation from environmental health researchers. If you are in a high-risk zone identified in Point 1, this is the most direct, actionable upgrade you can make to your home environment, and it addresses multiple air quality threats simultaneously, not just this one. Before we get to what you can actually do starting today, here is the question that researchers are still sitting with. If existing monitoring systems were not built to detect this compound, how many other novel compounds are currently in U.S. air that simply haven't been looked for yet? This is the part that resolves the question opened at the very start of this video. You don't know what the safe exposure level is because nobody does yet. So what is the rational, non-panic response when the data is incomplete? Here is a framework used in environmental health research called the precautionary approach, and it translates directly into 3 concrete actions you can take this week. Action 1. Establish your baseline exposure risk. Go to the EPA's AirNow website and enter your zip code. Then cross-reference with the Environmental Working Group's PFAS contamination map at ewg.org. If your location shows proximity to flagged industrial sites or falls within a documented high-concentration corridor, you may consider upgrading indoor air filtration as a precautionary measure. Action 2. Upgrade your indoor air filtration. As covered in the previous section, HEPA plus substantial activated carbon is the specification you need. Indoor air in a filtered environment can be meaningfully cleaner than outdoor air, even in a contaminated zone, because you control what enters. This is the single highest impact physical step available to you right now. Action 3. Reduce your total PFAS burden from all sources simultaneously. Because this compound accumulates and there is no excretion pathway, reducing exposure across all vectors matters. That means filtering your drinking water with a reverse osmosis or activated carbon drinking filter, not a standard pitcher filter, which does not remove PFAS effectively, and reducing your use of non-stick cookware, waterproof food packaging, and stain-resistant treated fabrics, all of which are documented PFAS exposure sources. The honest answer to the question this video opened with is, we do not yet know the safe airborne threshold because the research is weeks old and the regulatory process moves slowly. What we do know is that PFAS accumulates, that this detection represents a new exposure pathway on top of existing ones, and that the actions above reduce your total load in ways that are well within what a household can do without waiting for an official guideline. You do not need a government threshold to decide that less of a bioaccumulative toxin in your body is better than more. That decision is already supported by the science. Here is what we want to know from you. Drop your state in the comments right now and tell us whether you were already aware of PFAS contamination in your area before watching this video. We read every comment on this channel, and your location data helps us build the next video on which specific regions have the highest combined water plus air PFAS exposure, because that combined picture is actually the more important number for your health. If this video gave you something you can actually use, a clearer picture of your risk, a filter specification, or a map resource you didn't have before, then subscribing to this channel is how you make sure you get the next piece of this story when it breaks. We are tracking the EPA's response timeline to this detection, including when and whether they will establish an official exposure threshold, and what that threshold will mean for people in high-risk zones versus low-risk zones. That follow-up video will also cover the corporate liability question, specifically which manufacturers produce the compound, whether they are required to disclose, and what legal options exist for people in documented contamination corridors. Subscribe and turn on notifications, because that video is coming within the next 2 weeks, and it is the one where the implications get even more personal.